Okay, we are back at the Decode podcast booth. We are here at IPC Apex 2025 with Gayle Towell, and she is a content marketing specialist at AIM Solder. So why don't you go ahead and just kind of introduce yourself and what you do at AIM?
All right. Well, I'm kind of in a weird interdisciplinary role at the moment. My path to AIM sometimes confuses people. I've only been there almost 2 years. Prior to that, I was freelance technical writing. Prior to that, I was teaching college math and physics.
Okay.
And prior to that, I was getting master's degrees in those subjects. So it's kind of a winding path. I wanted to leave
Did
teaching.
you say master's degrees?
Degrees.
Like plural
There's
masters?
There's one in physics and one in math. The original plan was to get a PhD. I started in physics, but wanted to work with this guy in the math department on some mathematical physics. So then I moved departments, and then I had children. and so it goes. But, they're almost leaving the nest soon, so it's time for me to launch. But yeah, so I kind of had a winding path to AIM. And when I got hired, they were really looking for someone who could write content for the website, write up technical articles, handle presentations and documents. And one thing I noticed when I pivoted to freelance writing from teaching was you have people who can understand technical subject matter, and you have people who can write
about
well,
it.
but you don't have very many people who can bridge the gap.
Yeah.
And so I'm like, I have a superpower, because I spent years doing like creative writing too, and just building up my ability to write. And then when you teach for years and years, you get good at communicating things.
Yeah.
And so it was kind of a really good fit. And I remember when I was being interviewed for the role, they were trying to downplay. They were like, "It's really boring, guys. It's like like this, it's gray goop that you just use to stick things together with." And I'm like, "Oh no, I think it is exciting. I remember soldering back in my undergrad days." And then when you start really digging into it, and it's all this metallurgy and chemistry and physical processes that happen, there's so much there. And I have the ability to be fascinated by things like that. So it worked well. Yeah. And then I've just sort of been becoming a communicator. I've been doing other podcast appearances for AIM, giving presentations. I sometimes get involved in the public-facing research projects that we're doing because I have that science background. And it's been really easy to pick up all the information because a lot of it is just physics and science, and it's how that all works. So it's been great, and they've just sort of let me learn all the things.
That's awesome.
That's one of the things we love about Chris the most is her ability to translate. I think it was transfer efficiency with grilled cheese, right? Is that what that was? Yeah, like bridge those two, where anyone can understand that, right? Like it's an art form. It truly is to be able to, communicate like that. That's very cool.
Yeah, it can be tricky.
So let's talk a little bit solder paste specifics.
All right.
What are you seeing in the marketplace as contemporary challenges that the solder paste manufacturer has to meet? What's evolving? What's changing?
So the general trend in electronics forever has been everything's getting smaller and closer together. Yep. And so what that means on the solder paste side of things is solder paste is tiny little metal balls in a flux medium. Mm-hmm. And that's what makes it a goo. And the metal balls are classified by size. And
it's actually crazy when you haven't seen it. When you just see a naked eye view of what solder paste looks like.
And put it on a scope.
Yeah, then you see it under a scope. It's crazy, actually.
Yeah, and the real trick is, it's not just tiny metal particles. We try to make them as perfect spheres as we can. Because the more surface area you have on there, if it's irregular, the more it can oxidize, and that causes problems. So perfect little spheres that are very tiny, and you have solder paste is classified by type, and it used to be, way back when, type 2 was the industry standard, and that's a certain size of sphere, and then it became type 3, and now the most common industry paste is type 4, which I believe I should have remembered this right beforehand. I want to say 25
microns.
25 to 38 microns, I believe is the range for that. That's very tiny. Width of a human hair is about 100 microns. So these little metal particles are half that, quarter that. And so that's type 4. And when you print the solder paste, you're usually using a squeegee to push it through a stencil onto a board. And there's apertures in that stencil, and the paste has to make it through the apertures. Well, the apertures get smaller and smaller as the components get smaller and smaller. And at some point, you start reaching the limit of whether those particles are going to fit through that aperture.
Yeah.
And the rule, which is more a rough guideline, is you need to be able to fit at least 5 little solder spheres across there.
Yeah.
And so once you start getting beyond that, then you need to go to the next size down in paste. We say size down, the number goes up.
Yeah.
Kind of counterintuitive. But type 5 is sort of the next one after that. And then type 6, type 7. So what is on the market now? I mean, we've been making type 5 and type 6, and we do some type 7.
Who uses type 7? I mean, you don't have to say company, but I mean, what type of...
Weird people with too much time on their hands? Oh, apparently this guy. This guy uses
I'm not using it, but I have some customers that do.
You have to cut apertures for people who are using type 7.
Yeah, and I think the explanation that you just gave about when to use a higher type solder paste is important, because I'm not sure that everyone has that understanding. The solder paste particle size is critical for aperture fill, right? Mm-hmm. So it has less to do with it getting out of the aperture, but rather it getting in there. So I see some confusion in that point of view. And then another thing I want to bring up, you mentioned, the five ball rule, right? But as stencil foil thickness keeps trending thinner and thinner, we need to think about the Z as well.
Exactly.
Is the sphere small enough to tuck into that aperture so it's not being sheared by the squeegee blade?
Exactly.
It's becoming that thin.
Wow.
Yeah, I've seen some rules for how many balls height as well.
Okay, so what's your thinnest foil you've cut for?
25 microns, 1 mil.
Dang.
So imagine if you were trying to use type 3 paste in that. The height of the solder ball is
the solder ball is above the thickness of the thing. Yeah.
Wow.
So for reference, 4 mil, 5 mil tends to be the common stencil, which is 4 or 5 times what he just said.
Wow.
And when you start going down in solder paste size, there's also you need to do it when you're printing smaller and you have to fit the paste in the aperture, but there's also trade-offs, right? So some people think, just use the smaller paste and you'll get more stuff in there.
Yeah, just always use the smaller. Yeah.
But paste, so it's the tiny little spheres. What oxidizes is the surface of the sphere. And if you look at, for the same total mass of material, if you cut the spheres in half in size, you've doubled the total amount of surface area. And every time you cut the sphere diameter in half, you double the total surface area for the same volume, the same total stuff.
So you need more flux.
And you might need more flux, or you need better flux, because if you get too much flux, then you've got flux residue flowing everywhere.
Sure.
Right? So it's a balance, it's a trade-off. You might need to use nitrogen in your reflow, which makes it so the oxygen can't be there oxidizing things. So there's a lot of trade-offs. It's harder to control.
But in general, you actually want to use the largest ball size that you can get away with.
Yeah,
correct?
That's our current guidance, is use the biggest you can get away with. We are currently really trying to provide some industry guidelines around when to downsize. I'm actually going to be giving a webinar about that next month.
Cool.
And the idea is, so first, use the biggest you can get away with. Second, if you're in that border case zone, there may be ways you can play with adjusting your apertures a little bit. One example is if you have 01, 005 components, and a lot of people need to go to type 5 for that. Mm-hmm. But you can play a little bit. You can enlarge in the aperture a little bit. You can make rounded little corners so you get better release. And sometimes we've seen that work. So if you can get away with it, then go with it, right? If that's not working, or you don't have the ability to control your process that well, then it's time to go to the next size down in paste so you can get better volumes on your stencils. But then once you do that, if you've got one component that went down in size, and then you have all your other components, and then you change up your paste, now you're getting more volume and through all of your apertures. So you have to then adjust that down as well. So there's always those trade-offs around, it's not just
no single change affects one thing, right?
Yeah.
Well, it has a...
And with the diversity in, modern circuit assemblies, you're facing a lot of those challenges where you need to pay attention to the most critical things. But what does that do to the more traditional
everything
SMT in
else.
the assembly.
I ran my first 01005 job last year, and we were running Type 4, and then I switched to Type 5, and the result difference of coverage, right, was just...
In the print definition.
It was
I mean, it was a much sharper...
Yeah, same machine, same path, right, same calibration.
Same
What made you
stencil.
switch to 5?
Oh, and 005.
My customer, I think, wanted it, or was it you? Was it you? I don't remember. You want me to give you credit?
No.
It was you. It was 100% Elias.
Well, Gayle, this was awesome. Thank you so much for joining us.
Happy to talk with you.
I'm hoping that we can actually do a long form with her at some point. Actually,
Yeah.
have you come to
I
the
would love
podcast.
to.
I think Chris Shea pretty much told us that we had
Yeah.
to,
Oh,
so
okay.
we don't really
Yes.
have a choice.
She's
Okay.
my fan club.
Yeah.
Okay.
She's the
It's a
best,
good
right?
fan club to be in.
Well, thank you. This was great to meet you and to spend time with you and learn about what you guys do at Ames. So hope the show's gone
always happy
well
to
for you.
talk, So
Cool.
Thanks, Gayle.
Thanks,
Thank
Gayle.
you.